We were fortunate. We finished cutting grapes Saturday afternoon just as it began to mist. So we got that task completed.
That's good.
Okay, we're going to get started. My goal today is to finish up chapter 4 as we talk about climate. And we've been in the midst of a discussion about temperature. And temperature has a dramatic effect on plants. It is the most important factor that affects plant growth. And there are differences in a plant's reaction to different temperatures. There is usually a minimum temperature at which a plant will grow. Then there's an optimum temperature for a plant, and then there's a maximum temperature. So, and it's usually a parabolic relationship. It comes up and peaks and then falls off if we were to graph the rate at which plants grow. But it varies with the plant. We'll have certain plants that we grow in gardens and to a degree commercially that prefer cooler temperatures. Then we have a lot of plants like what are the agronomic crops, or horticultural crops that are grown in the area in which we serve that are more of a warm season plant. And then there are a very few plants that we have here that actually like hot weather. But when you get into the tropics, there are a lot more of those. But as a general rule, the plants that grow in this area, when the temperature gets much above 86 to 88 degrees, photosynthesis stops. It's when you reach that point, plants that we cultivate don't like it. So they cease to grow and cease to produce carbohydrates. So you know that as we talk about temperature, you've got several different aspects, and it like I say, it depends upon the particular crop that you're cultivating as to which one it is. We have learned through time that we can manipulate the temperature around growing plants. Was picking up pumpkins on Friday afternoon late, and the young man that I was purchasing them from has got he's had quite an acreage of tomatoes. I've been buying tomatoes from him since early part of August, and he had a question for me if I had any experience with row covers. And do any of y'all know what I mean by a row cover?
Road cover?
Row, R-O-W cover.
Is that like those, they look like miniature high tunnels that go down a row and they'll be a few feet high?
Yeah, that's one type for a particular crop. Those, what you're describing, is quite often used on strawberries and things of that type. But this young man has got about an acre. Well, I don't know how many he's got, but he's got quite an acreage of late tomatoes, and he's at an elevation of about 2,800 feet. So he's a little colder than what we are here, and quite a bit colder than you folks in the south side. But he has just begun to harvest tomatoes from these plants. So with the time of year that we've reached, he's expressed concern about whether or not he's going to be able to harvest these tomatoes before we get to frost or temperatures that are not conducive to those plants. And like I say, he's at a higher elevation, so he may be looking at a frost danger in the next 10 days, probably. And he had investigated enough that instead of the little high tunnel type row cover, he had found some that were he said there were 3 different weights of it, which meant there were different dimensions that he could purchase. But he had one, if I remember correctly, it was 42 feet wide and 1,000 feet long.
Wow.
And that would be big enough to, in essence, cover an acre. 42 by 1,000 is 42,000 square feet, where an acre 42,560. So, he could cover an acre of tomatoes with a single row cover. And with the status that this crop is, and they are, I don't know whether you guys are familiar with it or not, but it's actually a German Johnson. It's a pink type tomato that is highly praised in a lot of the retail produce markets in our area. He's been selling these tomatoes for $25 a box for a 25-pound box. So he's getting $1 a pound for them. And potentially I don't have any idea the volume of tomatoes that are on this acre, but I could imagine that he's probably got, if he can harvest the majority of them, I feel sure he'd have at least 1,000 boxes on an acre. So it would justify the effort that it would take, the cost and the effort to try to cover those, because in our area, in the area that he is, quite often we'll catch a couple of frosty mornings around the middle of October, and then the temperature will moderate and we'll get basically what's called an Indian summer, or another warm period for another 2 or 3 weeks, so it carries up into November. So if he can protect these things for a couple of mornings, a couple of frost events, he could potentially have quite a windfall from this tomato crop. If they're currently selling for $25 a box, he could easily get another $5 a box. So it would justify the effort. But this is one example of temperature manipulation by in essence covering this acre of tomatoes with a blanket. That's all it is. It's a thin protective layer. It's like a lot like what 20 years ago they used to cover tobacco plant beds with a plant bed cover. And it's in essence that. It's a little bit like if you're familiar with Tyvek, the material that they use protective insulation on new home construction is a type of Tyvek.
It's kind of like, you'll see how it looks like it's wrapped in a paper. It's kind of that tough paper. That's the Tyvek. Yeah.
And you just put it over.
Yeah, and I mean, you go to try to tear it or something, it's not going to tear. It's actually a bunch of fibers that have been worked together.
Okay.
But just so you've seen it, you just may not have known what it was.
And that again?
Tyvek, Tyvek.
Tyvek. Or stainless steel, like stainless.
Yeah.
There are a lot of spray suits that are made out of Tyvek. You'll see a white spray, coverall type suit. It's quite often it's made out of Tyvek. It's a coverall that you'll put over your clothes when you begin to put pesticides on. So,
yeah, just a cheap disposable.
Yeah, it's a throwaway deal. So.
And it doesn't.
It doesn't absorb moisture. It's sort of water repellent, and it would be the same thing. It'd just be a real lightweight blanket that he's going to use. But the point being, it is one example of a method of protection against lower temperatures. We talk about, we mentioned a little bit the other day about using different types of frost protection for blossoming plants, whether we're talking about apples or peaches or strawberries. Strawberries, we can do it very effectively with a sprinkler irrigation. We can't do that with tree fruits, because the accumulation of ice on those will break the trees down. But they will use a sprinkler irrigation to protect strawberry blossom. And quite often they'll use some sort of wind movement to prevent frost in tree fruits. Have any of you ever seen frost form on a windy night or windy morning?
Yeah.
No, he doesn't do it.
I don't know what they want.
Because you may see a freeze situation, but you don't see actual frost. Frost occurs when you've got situations with the temperature drops low enough that you begin to get ice accumulation either on the surface or within in a blossom. And one of the proven methods of frost protection is a wind machine. Or I have seen when I worked in Winchester, there were a few growers that had apples that were planted in low areas that they really shouldn't have planted, but probably 3 years out of 5 they were able to get a crop there without any frost damage. So those other 2 years they would contract with helicopters to fly over those low areas to mix the air. That's just one of the mechanisms that's used.
As far as sprinkling the water, Mr. Ayers, so the water would be like not cold, correct? Or does it matter what temperature?
No, it doesn't matter well, it does matter, but it's liquid water. And as I thought we talked about this a little bit last time, but we may not have. We may have been right at the end of class. What happens with, let's use strawberries as an example. The strawberry producers that I know, that I've had experience working with, will have temperature sensing devices in their strawberry fields, and they'll have alarms hooked with those in their home or on their cell phone or something. And when the temperature in their strawberry field gets to, say, 36 degrees, and I'm talking about the temperature, at the level of ground level. These alarms will go off, and these guys will go out and crank up their irrigation systems. And these will be irrigation systems that sprinkle. They're sprinkler type systems that will dispense water over the entire field with just a sprinkler hit, just like a lawn sprinkler that goes and twitches back and forth. And their goal is to keep liquid water flowing on that crop until the danger of frost has passed. And quite often it may be 3 o'clock in the morning that the temperature gets down to 36. But according to weather forecasters, and they recognize that the dew point that night or at that time may be 30 degrees, which means that the temperature potentially can go to 30. If it goes to 30 without any sort of protection, it's going to kill all those strawberry blossoms that are coming out. And they can't stand this. They can't afford it. So they will begin to apply this water, and usually about an hour before sunrise, the temperature will drop to 32 or below. And at that time, the ice begins to form on those flowers and the land and all the vegetation that's there. But as long as they continue to disperse the water, the flower and the strawberry plant will never go below 32 degrees. Because of this one thing, and it's titled The Heat of Fusion.
Yes, I haven't read it.
Okay. But the heat of fusion is the very small amount of heat that is given off when water changes to ice. And as long as that is continually done until all that ice melts, you are able to protect that crop. Now, I have known of a couple of guys that didn't fully understand the process, and the sun would get up, the temperature would still be down about 30, and they think, oh, well, we've accomplished our goal. And they would turn the sprinklers off, and the point they turn those sprinklers off, the temperature drops. That water's no longer being applied, so the temperature drops down to whatever that air temperature is. Quite often it's 28 or 30 degrees. And it'll kill that plant, kill that blossom, because that you're not getting that little bit of heat given off as that ice is formed. And you got to do it until all that ice melts. And it can create a mess. It makes the fields muddy. It can create disease situations with all the water going on. But it's still better than losing that entire crop to the frost. But it only works, you've probably seen on TV citrus growers trying to protect orange groves in certain situations. They use sprinklers and that. That's not really a good method because it creates such a weight of ice on those trees and they tend to break apart. So, but it is very effective on row crops with strawberries. I've even seen it done with tomatoes, some cucumbers and things of that type in Florida that they've used it. So it's just one mechanism that we have, and the principle that enables it to work is this idea of heat of fusion. Fusion is what we're talking. The term fusion means when it's transferred from a liquid phase to a solid phase. That's the act of fusion. The process is called the heat of fusion because there's heat given off. You and I would never feel it. We wouldn't know it. But there's just a very little bit of heat that's expelled when that happens. And that's the principle that enables that to work. So, any other questions about that? That was a good question. So, and I hope I didn't get too verbose on it. I'm trying to tell you what we were doing.
Thank you.
Anytime. As we talk about weather and so forth, air currents and air movement are a key factor in all of our weather conditions. You mentioned the fact that it was extremely muggy this morning and was that way yesterday. Why? Why is it that muggy right now? It's not normal for it to be that oppressive right now. What's
because it's living
Storm
and like from down south.
pulling in.
Oh, whether they can hear you or not, Tyler, go a little louder.
I was saying, isn't it because of the heat waves that we've been getting down south from tropical storm?
Yeah, that you're swinging at it. But the point I was making, it's the air movement. Right now, we're getting a flow of air coming up from the Gulf, off the Gulf of Mexico. The Gulf of Mexico is warm. It's extremely warm now. This is one of the reasons that this tropical storm went from a tropical storm to a hurricane pretty quickly, because it was out over the warm water in the Gulf. And we're still under that flow of air. Now, there is a cold front just to our west, but it doesn't have any steering currents to push it down to us. I think there'll be another front that comes down and reinforces that one probably Thursday, and will push out this muggy mess that we're in right now. But this is an example of air movement, and air movement is somewhat seasonal. During the summer, late spring, summer, until about this point, we get a lot of the air coming off the Gulf out of the southeast, and it creates higher humidity and the opportunity for thunderstorms that we get. Now, when we're in one of those situations and one of these colder air masses comes down out of Canada and sweeps across the upper Midwest, if we're in a condition like we're in right now, it creates a lot of churning and mixing and creates storms that can be pretty violent. That's one of the reasons that we have had as many tornadoes as we've had. There was an incidence of a tornado in the western part of North Carolina early, I guess it may have been the night before last.
Really?
Yeah, it hit, actually in Wilkes County in North Carolina, which is fairly mountainous. They don't normally get tornadoes because of their terrain, but it was a product of the turbulence that was associated with that tropical storm and the mixing of the air. The air currents control a lot of, most all of our weather. And, it's a major undertaking to realize that. And that's the reason we had this weather balloon the other day, because that's one of the things that the Weather Service uses to measure the differences in the different strata, the different layers of air that we've got over us, and it measures the wind currents. I'm hopeful they'll send me something back when I mail that recorder in to tell me where that weather balloon originated. I would like to know. I have a feeling that it was somewhere in the central part of the country, probably in the Mississippi Valley, but I don't know that. But it's when we get into a little later, probably mid-November through March, our weather will be controlled by a more northwestern flow of colder air, and it's always an interest to me how those things develop. A couple of years ago, we had some really cold weather that came from cold low pressure systems that originated in the Arctic Circle, and they swept farther south than normal, and we got below zero temperatures because of that air movement. They call those and right now it escapes me what they call those, but it was basically a low pressure system that originated up there and brought a lot of extremely cold air on us. But the weather's controlled by these air movements. As we talk about these air movements, have any of you experienced a hailstorm this summer, this spring or summer?
No. Not this summer or spring.
Are you familiar with what I mean when I say a hailstorm?
Yes, sir.
Okay. And thank goodness, knock on wood, we don't have too many of them in our area, but in some areas, hail is a major factor in the weather. Do you know how a hailstone is formed? You got any idea?
Isn't that when the water droplets freeze and get blown back up into the clouds and more water accumulates around it?
Would they freeze in the cloud?
Yeah, it is. It's when you have extreme differences in temperature. Warm air close to the ground and extremely cold up high. And you get this circulating turbulence. And this past spring, there were several storms that developed in the Midwest, and some got even over into the North Carolina area south of us, that had hailstones that it was common to have them the size of a golf ball, but there were several of them that were the size of baseballs, and I saw a few that were the size of the grapefruit. Now, go ahead.
When was that?
This past spring, late spring. And I don't know, have you ever, go ahead.
Was it like early spring?
Yeah, early spring,
Early spring?
late March.
I think I know what you're talking about. We had a hailstorm down by the Kerr Lake, and that put like serious dents on our truck and totaled some vehicles, stripped trees.
Yeah, they can be catastrophic. And if you imagine being outside and a piece of ice the size of a softball hits you, what's it going to do? If you don't have a hard hat, it's going to cause as a concussion. It can be dangerous. I've got my old truck that I run back and forth from home to work. It's a vehicle that I bought that had been reclaimed in a junkyard. The guy, I got a friend that buys total type vehicles and reconditions them. And I bought this truck and wasn't for, I guess it was 6 or 8 months later, I happened to get in the bed of it and happened to notice the top of it. And the top of it had been in a hailstorm, just like what you said. You know, it had little dings the size of nickels all across the top of it where hailstones had hit. So,
Yeah.
but hail it's a product of the wind from these turbulent storms. And normally just an average run-of-the-mill thunderstorm will have cloud tops that'll run 25, 28, maybe 30,000 feet. But when you get these much larger storms that may go to 45 to 60,000 feet, the weather forecasters now with the Doppler radars can essentially predict when and where hail is going to form because of the elevation or the height of these cloud tops. So, but point being, that's still a product of wind. It's a churning of the wind that occurs. So.
I went through the hailstorm that Chapman got around January or February last year.
Was that a question?
No, I'm just saying this discussion reminds me of that.
Mm-hmm. Yeah. But hail usually is associated with a thunderstorm. Now, we'll get other types of little particles of ice that occur
Yeah, that's where I live.
in the winter, and usually that is referred to as sleet. That's a little frozen rain particle that in warmer levels of the atmosphere, you'll begin to get rain, and we've got cold air trapped close to the ground, and that water will come through that cold air, and it will create little balls of ice, which are called sleet. And they're a little bit like marbles or roll ball bearings when they're on the highway. It can make it pretty dangerous.
Yeah, but what we got was like full-size, quarter-size hail that was coming down with a really bad thunderstorm.
Okay, that was hail. That's a thunderstorm. So that's
With here.
Actually, think about it, it was only 2 weeks after Christmas when we got that really bad freak storm.
that would be unusual. As we talk about air movement in respect to
This is terrible.
plants, air movement is highly desirable as we attempt to grow a crop, whether we're talking about pumpkins, or whether we're talking about grapes, or whether we're talking about apples and peaches, because the air movement through what we call the canopy or the plant itself, that area that is covered by leaves is called a canopy. And the air movement through canopies is highly desirable because it helps to reduce the humidity that exists in that microclimate in which the plant is growing, because the plants themselves are transpiring and giving off moisture. And if there's not air movement, the humidity within that canopy will get highly elevated and be very conducive to the incidence of disease. So, if you're growing apples or peaches, or in my situation, grapes, you've got to do something to manipulate that canopy to facilitate the reduction in the incidence of disease. With the grapes that we're growing right now, we do what we call shoot position. In other words, as the grapes grow out in the spring, they're pretty wild, they go every which way. We go through and put the shoots up to form a narrow canopy where the leaves are. But after we do that, we go through and actually pull a percentage of the leaves off to facilitate the air movement through there. If you don't, you get disease buildup. You can't spray through that. That's one of the reasons that commercial tree fruit producers, prune trees. They want to increase the air movement and increase the light that gets into the interior portions of those trees. So it, again, reduces the incidence of disease and allows for better spray coverage. So air movement is slowed by heavy vegetation. So we want to make sure that we can facilitate that. One question that quite often comes up on tests is what gas is in the greatest percentage in dry air? Anybody got any idea?
CO2? Oxygen?
Nitrogen.
We've got three guesses, and that they are usually the three choices that you have on the blanks, on the test. One of those was correct, and the other two were not.
Greatest.
What gas is in the highest percentage in dry air?
Dry air?
In dry air. I say dry air because I'm excluding the moisture, the water. So what gas?
Probably oxygen.
Oxygen is number 2.
I was
We
gonna
just
say
said the
oxygen,
answer.
because that totally makes sense.
Yes.
Nitrogen.
What was your answer again?
Nitrogen.
Nitrogen.
That's correct.
Nitrogen is correct.
I don't know.
In the air that exists where you guys are and where we are, if we say that it's dry air, 78% of that air is nitrogen.
Interesting.
About 20 to 21% of it is oxygen, and about less than 0.04% is carbon dioxide. And then everything else is other gases. There's a bunch of those.
Bunch of trace gases.
Bunch of traces, yeah. So, but as we look at the idea of the atmospheric conditions, nearly 78%, 77.5% of the Earth's nitrogen is in the atmosphere. So, with that being the case, we've been talking about thunderstorms. Is there a benefit respect to soil fertilization from a thunderstorm? Is there a benefit? What happens when we have a bolt of lightning?
Electricity.
It's electricity.
And so.
But that bolt of lightning going through the atmosphere will actually pull part of this atmospheric nitrogen out and leave it where it can be deposited on raindrops. So you hear people say that my yard greened up after the thunderstorm. Part of it is the water, but there was also some nitrogen that was dispensed through that water as a result of the lightning in the thunderstorm. It actually nitrifies that. So
does this percentage of nitrogen affect our brain at all by breathing it in so often?
I can't answer your question. I've never been without it.
Because they say we're.
I don't know. It may affect it, but it's not a negative. If you didn't have it, you'd be in a lot worse shape.
This is a question I will ponder. I'll do some research.
Yeah, like why can't we use the rest? Like we only use like a certain percent of our brain.
Yeah, we can. Only use it.
Don't try to ponder it without that, okay?
Okay.
All right, as we talk about the nitrogen and so forth, is there another mechanism that which we can gain nitrogen out of the air that would be beneficial to plants?
Nitrogen fixing bacteria on the roots of certain plants.
Absolutely. And you say certain plants. So what kind of plants are we talking about?
Legumes.
Legumes. What do we mean by legumes? I'm not picking on you. I'm just trying to follow a train of thought. What's a legume?
Peas,
Chickpeas.
beans,
Certain vegetables.
I believe alfalfa, clover, and I think redbud trees are also
Green
legumes,
beans are
I
too.
heard.
I think you've hit the broad spectrum of what we're talking about. But legumes have the ability, with the addition of a rhizobacter bacteria, to be able to extract nitrogen from the air and deposit it in the soil. And, you know, that may seem like an insignificant thing, but it is a key factor in the manipulation of crops that are grown in the area in Southside. Not so much in Southwest because they don't rotate the crops that we're talking about. But when you're talking about a crop rotation of wheat, soybeans, and corn, the soybean is the legume that pulls the nitrogen out of the air and deposits in the soil. So quite often you see a good farmer grow a crop of soybeans and then follow it with a crop of corn, because the soybean is going to deposit nitrogen in the soil, and the corn is a heavy nitrogen feeder. It requires a lot of nitrogen to produce a crop. So they'll use a sequence of that type. In our area, they do quite a bit of production of the corn and soybeans also. But they're also using a grain crop in there too. So, but that's what we're talking about with the nitrogen being deposited from the legumes. And quite often on a test, there'll be something for you to identify what is a legume. So it's a crop that has that ability.
Is that something we'll have to know for our test?
I would think we've discussed it this morning, and you probably would be exposed in that situation. Okay. When I remember the things, I'm trying to bring them out to you. Sometimes I forget, but there may be some other things. As we talk about atmospheric composition and gases, the term ozone comes up. Any of you got any idea what ozone is? How does it affect us? Is it a plus or is it a minus? We benefit from it.
It shields us from radiation.
Yeah, from the
And the
UV rays and
violet
everything.
rays,
Yeah, the UV violet
yeah.
rays from the sun.
yeah.
We also are killing it where we were.
They may not hear you, Tyler. Speak a little louder.
I said we were also killing it.
Killing what?
Killing the ozone.
Like,
All
like,
the aerosol cans everywhere.
Yeah, there has been some discussion about reduction of the ozone layer. The ozone layer is a layer of O3. Instead of oxygen, which is O2, O3 is ozone. And it's a molecular layer of gas that, in theory, protects us from some of the harsh rays of the sun. And it is a factor that some of the scientists are saying is contributory to the global warming situation. And there has been a reduction in the ozone layer, particularly on the polar areas, which is changing things. I'm gonna run through. I've got about 2 more slides here. We'll take but a second. Sulfur dioxide is a product of coal combustion, and it is very injurious to plants. There used to be a lot of coal-fired plants in the Midwest that would burn coal, and in doing that, they were creating a high percentage of sulfur dioxide in the atmosphere that was moving towards us. It would hit the western edge of the Blue Ridge Mountains, and when we had rain and so forth, that sulfur dioxide would be brought down and precipitated onto the mountainside. And in doing that, it would create what was actually at one time called acid rain, because the sulfur and the water creates sulfur dioxide or sulfuric acid. And it was affecting plant growth, and particularly the little animals and so forth that were in the mountain streams. There's another material in the atmosphere called ethylene, and it's a naturally occurring gas. that is a product of some fossil combustion, and it's also a product of plant hormones. And I'm gonna quit right there. We'll get started. I want to talk a little bit more about ethylene to make sure you guys understand what ethylene is, because there's several things about ethylene that I want to make sure that you understand. We'll pick that one up when we get together on Thursday. Talk about ethylene, then we'll get into the other chapter.
Okay.
All right. Have a good day. We'll see you Thursday.
See you Thursday. Oh, hey, I sent you an email with a picture of the hail.